Hello everyone, I'm Sebia Godfrey and I'm going to be taking you through inverse Laplace transform. But before, we are going to visit the essential Laplace transforms. And the essential Laplace transforms, we must know in our mind. Laplace transforms. First of all, you should know that the formula of Laplace transforms are the same as Fs, which is the same as from integral from 0 up to infinity of ft a negative st dt. Now from this formula, we are going to be generating different Laplace transforms by calculations, which I know everyone is well equipped with concepts of integration, putting in the limits, and so on. That one I will not do. That was just part of our formula. Allow me to rub it so that I give you an essential formula for Laplace transforms. Now I'm going to draw it in a table form. I give a function, I give its Laplace transform. The first commonly used function is e a t, exponential at. We analyze this element a is our angle on t. So from that one, you should know that it should be 1 minus s minus a. That is uniform, meaning that if it was a, power e negative a, this angle where there was a, it's now negative a. It will be 1 over s minus a, which will equal to 1 over s plus a. Simple as that. And now for t power n, which is exponential t, it will be n factorial over s n plus 1. Yes, let us continue with the other ones. Another one, we shall have cos 80 and sin 80. These ones I'm going to explain them at once. You should first know the denominators, s squared plus s squared. Now look at cos and sin. What letter starts with the s? What trig function starts with s? That is sin. So we are going to use s and a, but we are going to choose which is s and which is a. Now for s, it's going to go to that trig function that does not start with s, and that is cos. So here we have s, and the following has a. And now, for these ones, after knowing that cos has s and the sine has a, whereby they are s squared plus s squared, s squared plus s squared, now we are going to go to cosy and sine she. And now, cosy, if you are remembering very well, of course, you just change something a little. Now we are going to find that this is the same as for these ones with h's, this one turns into minus, but it remains the same. And another one, get what starts with s and that what starts with c. Then we knew that that what starts with s is the one which takes the a, And that one which starts with a C is the one which takes the S. What else could be needed and crucial for a learner to know before attempting this? For the further, I will be showing you. Now, let us proceed to other special kinds of Laplace transforms that one could need to know. One is Laplace transform of exponential at times ft. Remember, we are going to find this one. Remember, Laplace transform of ft give us fs from the definition. But now, instead of ft, we are having exponential at ft. Now, you don't rush to find the whole of Laplace of exponential at ft. What we are going to do is simple. We are going to first find the Laplace transform of ft, which is fs. And after finding fs, to get this Laplace transform of e at t, first identify a. These are the procedures. First identify a from exponential at t. Then fs, which we saw here from the Laplace transform. Then calculate fs minus a, meaning that whenever there will be s, you'll substitute it with s minus a. After calculating the Laplace transform of t, which is fs, and that is how we calculate the Laplace transform of the exponential e at t. And if we leave that, we are going to find the Laplace transform of what could it be that? F at t. And it will also come from Laplace transform of ft, which is equal to fs. This is ft. Forgive my handwriting. But this one will be simply 1 over a f s over a. Meaning that even this one, first find only Laplace transform of ft without this constant a. Then proceed with this formula of 1 over a fs over a. After identifying a, as I clarified in the first one. Let us go to our examples of Laplace transforms, which will lead us to inverse Laplace transforms. Hope you follow. Now let us practice this. Laplace transform of E 2t. And this is going to be e2t is going to be following the exponential. Now our a, first identify our a is 2. But remember this Laplace was 1 over s minus a. So our a is 2. So it will be 1 over s minus 2. That is the first practice question. And now they can trick you. They can give you a product rule. How? They can give you a product rule which is L E O T E to T. Then here you have to first follow the procedure of adding the powers. It becomes E to the 60 because we add 40 and 2t. And now we know that this will be 1 over 6, 1 minus s minus 6. For exponential, let us do that of negative. Then we'll proceed to other functions. That of negatives, Laplace of E, negative 2t. Remember the 1 over s minus a. But now it's going to be minus 2 because our is minus 2 and becomes 1 over s plus 2. What about L? E, negative 40 times E, negative 2t. This is done as the first one of multiplying by using the law of indices. And now, I think that I've explained enough stuff on exponential analysis using Laplace transform. Now let me proceed to that of t, powers of t. But we have to recall that Laplace of t to the power n will be n factorial over Sn plus 1, meaning that L t squared. Here, we have to first analyze n. We'll see that n is in the position of 2, meaning that where there is n, we are going to put 2. And it will be 2 factorial over s 2 plus 1. And this will be 2 over s cubed. As simple as that. Here, let us add Laplace transform of t to the power 3, which will be 3 factorial over s power 4. You practice that. And this is 2 to the power 4 times t squared. And this will yield, you first add the powers, which is 2 to the power 6, meaning this will be 6 factorial all over s to the power 7. And again on the powers, that only acts when the power is a whole number. But there are some special cases where the power won't be a whole number. And you have to know what we will do when that power is not a whole number. And now I'm giving you what you will do when the power is not a whole number. And the formula will be L T N minus a half will equal to 1 times 3 times 5 times 2n minus 1 root pi all over 2n Sn plus a half. How are we going to apply this one? Meaning that these ones are going to be powers over a half, like a half, 3 over 2, 5 over 2 in that range. Meaning that this is n minus a half. Like they will give you like t to the power half. you have to first arrange it in this format, and it will be t into 1 minus a half. You have to make sure that what is up is satisfying what is down. And we know very well that this Laplace transform, because they want the Laplace transform of t power half, and we have tried to organize that 1 minus a half is the same as a half. And now our n is becoming 1. So we shall start from 1 up to 2n minus 1, whereby our n is 1, meaning that plug the value of n in this value, you get 2 times 1, 2 times 1, that is 2, minus 1, that is 1. Already I'm having my 1 here, so we don't continue with these values because there is no way we are going to generate them, because we are only stopping on 1, which is this last term, times root pi all over 2 power 1, our value of n, times s 1 plus a half. And this will be root pi over 2 s 3 over 2. What you should know in mind that whenever you're having any fraction like a half, you have to first put it in this way of Laplace of 2 into n minus a half. Meaning that in this case where we had a half, we know that what value of n do we subtract? What value of n, whereby when you subtract a half from it, we get a half. That is 1. You arrange it in the form of the equation, and then you apply the equation, meaning that this one is in the position of n. 1 is in the position of n. So where you see n, you replace it with 1 as I did. You first know the formula, then the rest is what? Is history. Now, let us do another trial here regarding this. Another trial will be L T negative 3 over 2. And we know that this is the same as L T negative 2, or it will be negative 1 minus a half, because this one gives negative 3 over 2. But when you look at this one, it's giving us negatives, and this one is acting on positives. So once you sense a negative, maybe another formula can work, or you made a mistake in copying the question. All of us can't say the same thing. You consult the neighbor, even if it's the exam. Let us try 3 over 2. This will equal to L T 2 minus a half, because 2 is the same as 4 over 2. 4 over 2 minus a half, that is 3 over 2. And now we identify the value of n. Our value of n is 2 according to the formula up. So we start applying. We start with 1 times. Make sure that you check in this 2n to get the value that we end with. Like the other 2n minus 1 was 2 times 1 minus 1, which was 1. And it was already my first value. That's why I stopped there. But if it's 2, if you continue putting 2 here, it will be 2 times 2. 2 times 2, which is 4, minus 1, which will give you 3. But I think that is the last value of n, because now n is 2. We have got this first one, which is 1 times 3, after putting this last term of 2n minus 1, then times root pi all over 2 to the power 2 s 2 plus a half, which is equal to 3 root pi all over 4 is 5 over 2. Just have our formula in the mind, then the rest will be calculation. Organize your number into this format of n minus 1. Apply the formula. That is all. And you will be enjoying the mathematics there. And now after leaving the powers of t, I'm going to go to sine and cos. And you have to be remembering very well our formulas that we looked at before of sine and cos. This is sine and cos. How about if we have sine 40? But remember, we said that sine 80 is the same as a all over s squared plus s squared. Now we want to identify our a. Here our a is equal to 4, meaning that this would be 4 all over s squared plus 16. This is our Laplace transform of sine 80. And this is the Laplace transform of sine 40. Instead of a, we have replaced with a. And for cos, we have to remember that for cos, instead here up was s over s squared plus s squared, which will be s all over s squared plus 4 squared, which is 16. Meaning that you should ensure that those formulas are well equipped in your head. Try as much as possible. I was getting disturbance in that, but as time went on, I started mastering whatever, and now I'm a master. So hard work pays, practice makes perfect. Now we are going to Laplace transform of sine h of 40. But remember, we get this of sine h 80 as a or over a squared minus a squared. The only difference, the other one was plus, and this one is minus. But our a from this one is 4 by comparing. Meaning this will be 4 over a squared minus 16. Let me leave with you an assignment here, which you try out in your free time to show that you understood Laplace transform of E, B, T, Laplace transform of E, A, T, E, O, T, Laplace transform of 1 over E, negative 80 plus 40, Laplace transform of T power 3 plus 2t, Laplace transform of cos 40. First copy that. Anyone who can take a screenshot can take. But for now, this is number 1, number 2, number 3, number 4, and number 5. I hope this class will stop here. We are going to continue with other classes expressing other concepts. This was just the basic of the Laplace transforms. Thank you all for listening. This is teacher Sylvia Godfrey. Subscribe on my YouTube channel for more videos.